So hi everyone, I'm Tania. I'm one of the Applied ML interns. I'm currently in my final year at Queen's undergrad for Applied Math Engineering.
And hello everyone, I'm Radin and I'm a third year PhD student and I'm currently working as an intern in Retrieval Institute since January. And today we are going to present the conversational AI, the neural agent assistant section.
So the overall goal of the conversational AI project is to use large language models to develop tools that improve task-oriented customer service. So there are two major components that are involved in the project. So that's the automated speech recognition, which Rashid talked about in her presentation, and then the neural agent assistant for customer service support, which was Radin and Mai's focus for the term. So the neural agent can be further broken down into two work streams. So that's the task-guided question and answering and the task-guided dialogue state tracking. The end-to-end pipeline starts off with a question inputted by the user. Then the intent of the question is found, the relevant passages are retrieved, and then the answer generation model outputs an answer. So Radin and I mainly focused on the task-guided question and answering portion throughout our internship. And this consisted of the passage retrieval and response generation. We'll be presenting a demo at the end to show how these components work together. So this is the end-to-end pipeline for the passage retrieval. The overall goal is to find a passage that is the most semantically similar to the input question. So this passage acts as knowledge for the preceding response generation step. So this step is important because better responses are generated when there's information in a context that supports the input query. This process can be broken down into two steps. So the first step is the by-encoder, which retrieves the most relevant passage from a knowledge base. The second step is a re-ranker, which is based on cross-encoder. It re-ranks the passages that were retrieved by the by-encoder to reassess the relevancy of each collected passage. So looking at it more closely, the by-encoder is used to perform a semantic search retrieval. There are two different types of semantic search. There's symmetric and asymmetric. For symmetric search, the query and the passages are approximately the same length. But for asymmetric search, you usually have a query and you want to find a longer paragraph that's more related to the query. So in our case, our inputs were queries and paragraph length passages. So we use the asymmetric search. So how it works is that the query and passage are encoded into fixed size embeddings into the same vector space. And the by-encoder has a Siamese network architecture. The relevant passages are found by computing the similarity between the embeddings. So in our case, the similarity measure was the dot product, not the default cosine similarity. And this is because the dot product metric is better suited for cases where the passages are significantly longer than the query. So the next step was to add a re-ranker to further improve the search results. So with the by-encoder, from before, given a search query, the retrieval system can compile a list of hits that are potentially relevant. However, especially with larger data sets, some passages that were retrieved were not very relevant. And this is the purpose of the re-ranker. So as opposed to by-encoders, which can retrieve documents from a very large collection, a cross-encoder is only suitable for a small set of passages. So it scores the relevancy of all of the hits for the given query, and the output is then a ranked list of those hits. Both the query and passage are passed simultaneously into the network, and it generally achieves a higher performance than the by-encoder, since it performs attention across the query and the document. So I'll show a quick demo of the passage retrieval portion. So I'll quickly talk about the data set that I used. It's the ELI5 data set, which is a subreddit called Explain Like I'm 5. It basically covers a really wide range of random topics of people asking questions. So the data set that I used came from Hugging Face, and it includes related passages for each query. And that's aside from the answers. So the data set includes a query, answer, and related passages. And these passages come from Wikipedia. And every passage has a unique Wikipedia ID that comes from a knowledge base. So these are the passages that were used as the input for the bi-encoder embeddings. So these passages were then formatted into a list of passages. This train set was about 230,000. So that's how many passages there were. And in the interest of time, I pre-computed the embeddings. They're already loaded here. But basically, for both the bi-encoder and the cross-encoder, you load in the model. And then this is the function that does everything. It has the passage retrieval and then the re-ranker, which re-ranks the passage outputs. So I just have a sample question here. What is artificial intelligence? So when I run that initially, you can customize how many passages you want to retrieve. I just did 10 as an example. But basically the bi-encoder retrieved the 10 most relevant passages out of the entire set of passages. And then the re-ranker, which I set to output the top 3 from this list of 10, re-ranks them. And as you can see here, the top answer here and the top answer from the re-ranker are different. The re-ranker basically chose a more in-depth answer for the question, basically context for the question. So with that, I'll stop sharing so that Radin can take over.
Sure. All right, so let me share the screen. Sorry. Right, so I guess you can see the screen now. Right. So back to the pipeline. If you remember, we talk about the re-ranker and how we do the context retrieval. Now, if you look at the pipeline one more time, you can see that we use the passage retrieval section at the beginning to gather the relevant documents. And after that, we apply the re-ranker to cherry pick those documents that are most relevant to the query. And in the next phase, what we do is concatenating the relevant context to the query to form the input for our GPT-2, which is the answer generation machine in our case. As you can see here, this concatenating here happens before we are passing it. And the size of the context varies based on the model that we are using to train in the GPT-2. The bigger the GPT-2 size, more context we can include. And we have tried our pipeline on different data sets. As you can see here, we start with the MS Marco because it's a huge data set and somehow the center of the industry. And the data set has over 1 million queries with human generated answers. So the quality is good and there are different type of questions. And they are gathered from the Bing queries. And after that, we try to try different type of questions. One was the Amazon Q&A. This the data set is about the question that customers ask about the product before they purchasing it, and the answers are most of the times are the other consumers reviews on them. So we have around, again, 1 million questions here, 40 million reviewers. And the challenge here is that we don't have any actual answer for the question, but we have relevant comments on those. And the next data set that we use is the Eli5. This data set is gathered from a subreddit called Eli5 from Reddit, and has a relatively smaller set. We have around 270,000 questions. But one important thing here is that we have categories. So the entire data set and all the questions are categorized in 11 different subcategories. Some of them are related to the biology, some of them are related to the physics. So, and this helps the answer generation system to realize what kind of documents you should rely on and what is the topic of this question. And the other data set is the T-card. This is a gathered data set by the vector itself. It's based on the question FAQ side of the U of D about their T-card queries. So after the evaluation, we gather all the scores and we put it in the GitHub repo. I just put a screenshot of the stats here for the reference. It's actually growing. We are adding new scores to this table, but this is the current state of, as you can see. So moving forward to the presentation that we have and the demos that we have for the industry sponsors, we try to prepare some model, pre-trained models, the snapshots of the models for them so they can boost up their training on the conversational AI project. And currently we have different variations of the GPT. We have a small, medium, and large pre-trained models, and the architecture is just mentioned here for your reference. And also, as we suggested for the sponsors and the people that are using it, the users, we guarantee that the project is working on all the available GPUs in the Vector Institute. At the beginning of the project, a challenge that we had was that part of the code had some compatibility issue, and we wanted to make sure that the entire code, the entire project can work on every single GPU that exists in the ecosystem. And by now, we know that it can run smoothly on any resource that we have in Vector Institute. And we suggest that for the training, we use the RTX 6000, and for the inference, both T4 and P100s are good enough. And also some cases that we prepared for the users, and then we also prepare some demo Jupyter notebooks in the GitHub as well. The first case is that they want to start with a Zeroshot, so they don't want to train data set. They bring their own data set, and then what we suggest is to set up the context retrieval and re-ranker, and then run the end-to-end Jupyter notebooks. If someone wants to fine-tune, we prepare functions and the Jupyter notebooks so they can convert their own data set to the MS Marco format data set, which is the standard format. And then after that, they can do the fine-tuning. There's dedicated Jupyter notebook for fine-tuning. And then after that, the model snapshots can be saved and then tested. And for the evaluation, there is again a dedicated Jupyter notebook that you can load up the model and then load up the test set. And then at the end of the evaluation, they will get results. All the metrics that we saw in the dataset table, they will be all reported at the end. And those are really helpful because it's very inclusive, actually, the numbers that we have here. And one of the other cases is that what if we want to revise or put some regulation on the answers? Again, this is also supported here. The solutions are provided for the users. And I just brought it here so we can use a predefined list for the answer generation system if we want to detoxify the answer generator or use a blacklist. These are also provided for them, and they can test it on the end-to-end Jupyter notebook as well. So, and this is the QR code of the GitHub repository. Me and Tania actually prepared the demo for you on the Jupyter notebook that I want to present it to you. So if you don't have any question on this part, maybe we can move on to that.